Hello, Integrated Math 1. Welcome to lesson 2.3.1b. Ooh, and I've got the wrong page up. Hang on. There we go. There's the right page. Is that a little better? So we are just going to kick it off with a warm-up. The first one's going to look familiar to you. The other ones might look a little different. It's okay. Don't panic. See what you can do with it. Have a little faith in yourself. Go ahead and see what you can do with this. Hit pause to work these out. Hit play when you're ready to check your work. So the first one's pretty easy, right? H of 3. That just means everywhere we've seen x, we're going to plug in a 3. So negative 2 times 3 minus 5. Of course, negative 2 times 3 is negative 6. Negative 6 minus 5 is negative 11. Yay. But these start to get a little weirder. And that's okay. That's okay. We're going to do 2 times h of negative 2. So first of all, everywhere you see an x, I need to plug in a negative 2. So I'm going to do that everywhere I see an x. Hang on, I want my pen. Where's my pen? Oh, I hit the funky button. Everywhere I see an x, I'm going to plug in a negative 2. So negative 2 times negative 2 minus 5. But whatever I get here, I need to multiply the entire thing by 2. Ooh, so let's work our way through this. It's not that bad. Negative 2 times a negative 2 is, of course, 4. I'm going to multiply here. 4 minus 5, well, that is a negative 1, right? Right, yeah, so 2 times negative 1 is negative 2. Oh, look, we just got our answer. Hooray, us, yay. Here, I'll show you the pretty typed up version. There it is, I'll type it nice. So, similar idea here. H of 1 means everywhere I see an x, I'm going to plug in a 1, so negative 2 times 1 minus 5. But we're going to multiply this by a negative 1, and we're going to add 5 on the end. So be real careful with your order of operations here. Of course, negative 2 times 1 is a negative 2. Negative 2 minus 5, that is negative 7. Remember your order of operations, you do need to multiply before you add. So negative 1 times a negative 7 is a positive 7. And then, of course, 7 plus 5 is 12. Hooray for us. Yay. And last but not least, actually, I'm going to go ahead and again, I'm going to erase this and show you the pretty printed version. There we go. And last but not least, this last one, h of 0. So, okay, everywhere I've seen x, I'm going to plug in a 0. So negative 2 times 0 minus 5. But of course, we can see it's going to get multiplied by 5. And we're going to add 5. So again, watch your order of operations. Negative 2 times 0 is, of course, 0. 0 minus 5 is, well, negative 5. And 5 times a negative 5, we do multiply before we add. 5 times a negative 5 is negative 25 plus 5, which gives us negative 20. Whoa, my pen went wonky. Sorry about that. Here, I'll erase this and do the printed one. There we go. Okay. So today, guys, we're going to be transforming linear functions. That just means we're just doing stuff to our functions. That's all. So there are some important goals here. We're going to determine the effects on the graph of a linear function when instead of f of x, you add something to it, right? Like a plus d of some kind. Or if you multiply your function by something, a times your function, some number times your function. We already did a little bit of that, but we're going to dig a little deeper. We're going to graph linear function transformations expressed symbolically. We're going to show our intercept, always important. We're going to identify key characteristics of our linear graphs, right? Slope, y-intercept in terms of quantities from a verbal description. And we're going to prove, this is the big one, we're going to prove that a translated line and its pre-image have the same slope and are therefore parallel. We're going to prove that parallel lines have the same slope. And we're even going to write equations of parallel lines. So these are big ones that we're going to be doing over the next couple of days. So we have just one key term, which is basic function. So you've learned about linear functions and their characteristics, right? Slope, y-intercept, you guys can get pretty good about that. So how can you transform a function? And what effects do different transformations have on the characteristics of linear functions? So just to get us started on page 42, I'd like you to consider this. Line segment AB. It starts here at A, it goes up to B, with coordinates at A is at -8, -8. You may even want to write that on your paper. You might want to be like, that is -8, -8. And B is at 8, 8. So make a little note here, just something like that, so those guys are. So here we have this lovely line segment. And here's what I would like you to do with this lovely line segment. I would like you to take that line segment and move on the coordinate plane to translate the entire segment up 4 units. And then I want you to take that entire segment and I want you to translate it down 4 units. And I want you to describe to me how the points move. Go ahead and hit pause. Move it and move your segment up 4, move your segment down 4. What happened? What happened? Go ahead and hit pause. Work this out, put down your thoughts, hit play when you're ready to check your mark. So I'm going to use some other colors here. I used red there. So I'm going to use some other colors. So for my translate up, I'm going to use a nice blue. So I'm going to go up 4 units. 1, 2, 3, 4. Here's my new A. I'll call it A prime. I want to move this guy up 4 units, although it kind of puts me off the graph. That's okay. 1, 2, 3, 4. I'm like way up here. Oh my goodness. We'll call that B prime. And this is not going to be my best straight line ever, but it's not my worst ever. So there we go. We translated it up 4 units. What happened to our lines, guys? How did we move? Oh, we were also asked to translate down 4 units. I'm going to use a nice green, and I'm going to go down 1, 2, 3, 4. I'm going to call this B double prime because that's my second one. I'm going to move this guy down 4, 1, 2, 3, 4 again. I kind of go off the graph a little bit. That's okay. And again, I'm going to call that A double prime. And I can connect the dots, la la la, not my best ever. So how did our points move? Well, I can see on this first one, since I went up 4, it looks like instead of being -8, -8, I'm now -8, -4. Oh, my y coordinate changed, didn't it? And over here, instead of being 8, 8, I'm now at 8, 12. So my x coordinates didn't change, but my y coordinates sure did. It looks like we added 4 to each one when we moved up 4. And for my other one, looks like my new coordinates here are -8, -12. Looks like I subtracted 4 from my y coordinate. And for B, I am now at 8, 4. So again, it looks like I subtracted 4 from my y coordinate, doesn't it? All right, so how did my points move? Well, the points moved just straight up or straight down, right? There was no movement left or right. Everything just went straight up and straight down. So how did the translation affect the coordinates of the figure? Well, we were just looking and we noticed that when we went 4 units up, the x coordinate didn't change at all. The x coordinate didn't change at all. But we did add 4 to our y coordinate, didn't we? Oh, and when we went 4 units down, we didn't change the x coordinate at all. Again, the x coordinate stayed totally the same, but we did subtract 4 from our y coordinate. So the x coordinates are staying the same. But when I went up 4, I added 4 to my y coordinate, and when I went down 4, I subtracted 4 from my y coordinate. Okay. So they're saying draw CD on the coordinate plane so that it's a vertical translation of AB 4 units up. Compare the 2 line segments, describe how they're related. So you may want to erase what we did before and then go ahead and write a new segment. It's going to go 4 units up from here, but now we're going to call it CD. Go ahead and hit pause, work this out, describe how they're related, and then hit play when you're ready to check your work. So again, I just went up 4 units, and I labeled it C and D because they told me to label that C, yay. And as far as how they're related, I don't know about you guys, but I noticed that my lines are parallel. Did you catch that? Segments are parallel with CD lying 4 units above AB, but they're parallel, aren't they? So when we did that vertical shift, our lines ended up being parallel to each other. That's important. So let's determine how translations impact the graph of the linear function f of x. Now, we say the function f of x equals x is the basic function for the linear function family. I mean, check it out. It's f of x equals x, right? My slope is 1. I've got my y-intercept is 0. It is the basic function for the linear function family. And a basic function is just the simplest function of its type. That's all it is. So you can translate the graph of f of x equals x down 5 units by moving each point down 5 units, right? Down 5, down 5, down 5, down 5, down 5. And the transformed graph is labeled as m of x. So to translate the point -2, -2, which would be out here, you'd have to subtract 5 from our output value, from our y, because we noticed that when you translate up or down, it only affects the y-coordinate. It doesn't affect the x-coordinate. So our x-coordinate would stay the same, but our y-coordinate has us subtracting 5 to get to our new y-coordinate. So the coordinates of the translated point on m of x are -2, -7. So the original was -2, -2, but we subtracted 5 from our y-coordinate and we got -7. And of course, the coordinates of 4 other points are listed as well. So again, x's all stay the same, but for each of those y-coordinates, we had to subtract 5. -1 minus 5 is -6. Subtract 5. 0 minus 5 is -5. Subtract 5. 1 minus 5 is -4. Subtract 5. 2 minus 5 is -3. So when we went down 4 units, or down 5 units, I should say, we subtracted 5 from all of our y-coordinates. X didn't change. So consider the translated function m of x that we have here. Can you just take a moment to identify the slope and the y-intercept of the graph of the function? Because of course we said this is the original, right? This guy right here, where's my pen? There it is. We said this guy right here is f of x equals x. So we're like, it has a slope, a slope of 1, the y-intercept is 0. But what happens with my new guy, with my m of x? Can you write down what's my slope now for m of x and what is my y-intercept? Go ahead and hit pause, write it down, hit play when you're ready to check it. So I did notice that my y-intercept changed, right? My y-intercept definitely changed. I went from 0 to a -5. So my y-intercept changed, but these lines are parallel. My slope didn't actually change, right? F of x equals x is going up 1 over 1, up 1 over 1, up 1 over 1. But so was m of x. It was going up 1 over 1, up 1 over 1, up 1 over 1. So that means my slope is still 1, but now my y-intercept is -5. So if I were to write m of x, I would say m of x equals 1x plus -5. My slope, my y-intercept. Although we can clean this up, right? We don't need a 1 in front of the x, and instead of plus -5, I could just write it as a -5. So if you wrote this, that's fine, but it's a little cleaner to write m of x equals x minus 5. All right. Let's do this again. Translate f of x again to create a new function p of x, all right? I want you to translate the graph of f of x up 5 units, and you're going to label the new guy p of x. And once you've translated up 5 units, you're going to put your new points on your graph, all right? Hit pause, work this out, and then hit play when you're ready to check your work. So I went up 5, up 5, up 5, up 5, up 5, and again, I can use your pen and get my red pen back. So you can go up 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You probably don't need to do this many. 1, 2, 3, 4, 5. So I'm just going to move everybody up 5 and connect the dots. Yay! And of course, we need to label it. We're going to call it p of x. So I'm going to label it p of x. And then we want to fill this in, right? Well, we know that x coordinates don't change. So -2 is still going to be -2. -1, 0, 1, 2. So we said the x coordinates don't change. Great. But we moved up 5. So that means we're adding 5. We're going to add 5. Ooh, sorry for my little pen being funky. We're going to add 5 to all of our y coordinates. Fine. -2 plus 5 is 3. -1 plus 5 is 4. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. Look at that. We got new coordinates. Woo-hoo. For centennial. Again, just like we did with m, I would like you to identify the slope and the y-intercept of p of x, and I'd like you to write the equation for the function in general form. Remember, general form is just f of x equals ax plus b. Similar to your whole y equals mx plus b, right? Same thing, slope, y-intercept. So go ahead and hit pause, identify the slope and y-intercept, write the equation, and then hit play to check your work. Well, first of all, we knew that slope was not going to change. My slope is still 1, right? I'm still going up 1 over 1, up 1 over 1, up 1 over 1, rise over 1. But my y-intercept has changed. I can see my y-intercept is now 5. So my slope is still 1, but my y-intercept is now 5. So I can write it as p of x equals 1x plus 5, right? Slope, y-intercept. And actually, we don't have to have the 1 there, so I'm going to rewrite that as p of x equals x plus 5. So for the basic function f of x equals x, if you add a number to your function, it's a vertical translation of the function. If I add 2, it's going up 2. If I add a -3, it's going down 3, right? You get the idea. This translation affects your output values or your y values of the function. It doesn't affect x at all. If you add a number, it just affects your y values. That's it. And of course, if d is greater than 0, your graph shifts up. If d is less than 0, your graph shifts down. Fair enough. And how far it shifts is just the absolute value of d. So again, if I have f of x plus 2, I'm going to push everything up 2. If I have f of x minus 7, we're going to have everything go down 7. Pretty straightforward. So can you compare the values of f of 2 and p of 2? How did the transformation of the function affect the value of the function at x equals 2? Go ahead, hit pause, find f of 2 and p of 2, tell us how it affected it, and then hit play when you're ready to check your work. So f of x equals x. So if I plug in a 2, I get f of 2 equals 2. I can do that. We said that p of x is x plus 5. So if I plug in a 2, 2 plus 5 is 7. So p of 2 is 7. So how did the transformation of the function affect the value? It increased it by 5, right? So it's a vertical translation that increased the value of the function by 5. Fair enough. I have a new graph for you. I'd like you to consider the graph of j of x equals 2x minus 1. I would like you to translate this graph, and it's called j of x. I would like you to translate j of x up 4 units, and I'd like you to label it as q of x. Now here's the trick. I want you to then write the equation in terms of j. We'll talk about that in a minute, so don't panic. Start with the translation, and then we'll talk about how to write the equation q in terms of j. So go ahead and hit pause, work this out, hit play when you're ready to check your work. Before we get too far into this, I do want to point something out here. We said f of x was x and that p of x was x plus 5. So basically, we took p of x, to get p of x, we took f of x, and we added 5, didn't we? So maybe that helps with writing your equation for this guy. Now, first of all, it said to go up 4 units. So I'm just going to pick some points and do like 1, 2, 3, 4. And for here, 1, 2, 3, 4. And 1, 2, 3, 4. You don't have to do a ton of these, but I find it's easiest if I just mark some points. And I'll connect the dots and make my line, arrow on either end. It did say to label it as Q of X, so I'm going to label it Q of X and be a good girl. Now, we said to get Q of X, oopsie, just kidding. We took J of X and we pushed it up 4, which means, guys, we added 4 to J of X. Look at that. And you just wrote the equation for Q of X in terms of J of X. Yeah. So let's do this again. Let's take f of x and, pardon me, j of x. It is a j. Let's take j of x, and now can you translate it down 4 units, label it as r of x, and then write the equation for r of x in terms of j of x. Now you know how to do this. Hit pause, work this out, hit play to check your work. All right, so now we're going down 4. So again, I'm just going to pick some points and go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and again, you can do as many as you need to. I'm going to connect the dots. I'm going to label it r of x, and now we're saying we have r of x because we took j of x and we went down 4 units. So we're going to subtract 4. Yay! Good job. All right. Okay, this is all fine and good, but I don't want Q of X to be in terms of J of X. Can you rewrite Q of X and R of X in terms of X? So here we have our Q of X equals JX plus 4, right? We wrote that earlier, but we know what J of X is. So everywhere you see J of X, you can replace it with 2x minus 1. Can you do that and then clean it up and then do it again for R of X? Hit pause, work it out, hit play to check your work. All right. So instead of J of X, I substituted in 2x minus 1. But I have like terms, right? Check it out, because I have that plus 4 in the end. I've got some like terms, so fine. Negative 1 plus 4 is 3. Yay! So now Q of X is in terms of X, not J of X. I can do this again for R of X. We said it was J of X, but we subtracted 4, so fine. Instead of J of X, I'm going to plug in 2x minus 1. I'm going to combine my like terms. Negative 1 and a negative 4 gives me a negative 5. So R of X equals 2x minus 5. And now R of X is in terms of X, not in terms of J of X. Can you just take a moment? Can you compare the equations and the graphs of J of X, Q of X, R of X? Can you compare all those guys? Tell me what you notice. Hit pause. Tell me what you see. Hit play when you're ready to check your work. And I hope you're enjoying the sound of the backup beeper right outside my window. So I noticed that they all had the same slope, right? All of them had 2x. Every single one of them had 2x. They all have the same slope. They're all parallel, guys. They're all parallel. Guys, parallel lines have the same slope. That's important. That's important. So in the previous activity, we translated the function 2x minus 1 up 4 units, and we got 2x plus 3. Will these ever intersect? I hope you said no. They're never going to intersect. They're always going to be 4 units apart, right? So how does the slope of the image compare to the slope of the pre-image? If AB was translated up 8 units to create line A prime, B prime, guys, the slope is the same, right? If you're just translating up, I don't care how many units, you're translating up 8 units or down 5 units, the slope's going to stay the same. So these lines would be parallel. Now, Jillian and Ramses each write the equation of a line that is parallel to y equals 1/2 x plus 3 and passes through the point 2, 9. They have 2 different methods. You're welcome to read through these and decide which method you like. But can I show you the method I prefer. I actually prefer Jillian's method a little bit, and I'll talk about it. Again, you're welcome to use either method, but I'm going to show you what Jillian did. So Jillian took this and she said, okay, well, if it's parallel, they're going to have the same slope. Well, here, my slope is 1/2, so that's the slope I'm going to use. I also see I have an x coordinate and a y coordinate because, of course, the problem is I'm missing b, aren't I? I'm missing that y-intercept. So here's what we're going to do. I'm going to take y equals mx plus b. I know what the slope is. It's 1/2 because it's parallel. And I'm going to plug in a 2 for x, and I'm going to plug in a 9 for y so that I can solve to find b, right? So let's keep it simple. 1/2 of 2 is 1. Oh, that worked out nice. If I subtract 1 from both sides, I get 8. Oh, look, you just found your y-intercept. Yeah, so we can write the equation. Y equals, our slope is 1/2 x plus our new y-intercept, which is 8. Yay. Now, Ramsey's method also works. If you want to take a read through, that's totally fine. I like Jillian's method best. I find it's pretty direct and straightforward. So with this in mind, can you do this now? Can you write the equation of a line that is parallel to y equals negative 3x minus 1 and passes through the point negative 1, 5? Go ahead, hit pause, work this out, hit play when you're ready to check your work. All right, I'm like, hey, the line is parallel, so that means same slope. I can see the slope here. The slope is negative 3. Great, but I'm missing b. So fine, let's do this. Y equals mx plus b. I know what my slope is. It's a negative 3. Hey, I have an x and a y, don't I? So I'm going to plug in, instead of x, I'm going to plug in that negative 1. Instead of y, I'm going to plug in 5. And now we got this. Negative 3 times a negative 1 is a positive 3. If I subtract 3 from both sides, those cancel out. And I get b equals 2. Yay! I know what b is now, it's 2. So let's write the equation. Y equals negative 3x plus 2. If you would feel better writing it as f of x equals negative 3x plus 2, that's okay as well. So all I did is I used the slope from the first equation because they're parallel, and I used the x-coordinate and the y-coordinate to plug everything in to help me find my y-intercept. And once I have my slope and my y-intercept, I can totally write the equation. That's pretty magical. So as always, guys, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, please email me or come talk to me. Come talk to me. Lunch, office hours, whatever works for you. And I'll see you guys soon. Bye.